We're in the middle of that next call for heat, well, the same call for heat as the previous video that I took. And the main vent is now closed. And we're generating steam, which is going up to all the radiators. We're just still like 0.6, 0.7 inches of water column pressure. I know from experience when the call for heat ends, really ends, the vacuum gets formed that will take this gauge, to beyond its minimum. This gauge goes to -5 inches of water pressure, and so this, at the end of a call for heat, this needle will go pegged to the left, and it'll stay that way for several minutes. So what we're curious to see is during the CycleGard shutdown of 1 minute, what happens to the pressure. And the CycleGard should kick in, I don't know, in a couple minutes or so. We're in the middle of that same call for heat. The main vent's closed. There's steam throughout the system. I haven't gone and checked every radiator, but I'm sure that every radiator is seeing steam. The radiator vents have not seen steam yet. That will take some time longer, but right now the main line is completely full of steam. All the runouts are full of steam, and we're at 0.8 inches of water pressure. It varies a little bit. You can see it moving around. And any second now, the CycleGard should interrupt this call for heat. In the previous video, it interrupted it pretty much right at the beginning, just after steam production had started. But now it's been going for the next 15 minutes. It interrupts every 15 minutes, this model does. So any second now it'll interrupt it for the test. And the question is, what's going to happen to the pressure in the system during that 1 minute? I suspect it will, it'll go negative a little bit, but the main vent won't open. So what that means is the pressure is reduced below atmospheric pressure in the system, and then once the CycleGard turns the system back on after its 1 minute test, then the steam will readily flow back into the system. Due to the lower pressure there, it'll enjoy filling up that low pressure space. And we'll be able to see that and how long it takes on this accurate low pressure gauge that I have here. I believe 1 inch of water is equivalent to like 27 inches of water in 1 psi, right? So 1 inch of water is around a ½ ounce of pressure, close to anyway. Sorry about the vertical orientation of the video, but it'll let us see the CycleGard light at the same time that we get to see the pressure, so that's handy. This is the pressure that all systems should run at if they're correctly sized, at least until they fill up until all the vents close on the radiators. Then the pressure starts to rise. But my previous boiler, which was larger, it would build pressure. There it goes. There goes the CycleGard. My previous boiler would build pressure even when it was just supplying steam to the radiators, and that's not what should happen. Okay, so we dropped to 0 pretty quickly within just a few seconds. We're going negative now. -1 inch. Now it drops and then it sits steady for a while. So I don't know if, more steam is getting created during this time. Some still is getting created. There's still heat in the block that's getting transferred to the water. So some steam is getting created, and that's why I think it doesn't drop quicker or more deeply into a vacuum here. This is a very minor vacuum. The main vent isn't open. It's not letting any air in. The radiator vents, those are still open. So they're letting some air into the system. But they're all pretty small, so that may be why it was still able to go negative, even though all the radiators are letting some air into the system. So the CycleGard stopped its test. That minute went by, and the boiler's firing again. And it's filled that vacuum with steam, and now it's climbing again. Now we see the pressure rise even more than it was before. Now I think what happens here is all the radiator vents were open, and during that 1 minute timeout, the radiator vents all let air into the system, and air pulled down into the radiators and potentially into the runouts even. It's hard to tell exactly how much they would have drawn in, but that filled that space up with air. Some of that space could have been steam before, right? Some part of the radiators had steam in them, and the runouts all had steam in them. So during that 60 seconds, air is drawn into the system. And now steam is getting generated at the normal rate, and it kind of crashes into that air in the system. It's not released by the main vent, and because the main vent's been closed this whole time. So it all has to exhale out of the radiator vents again. And this may be the type of thing that Dan was talking about. I don't have the page number in my memory right now, but Dan was talking about expanded air in the radiators. I'm not sure I'd call it expanded air. I'm not sure this is what he was talking about, but in this case I wouldn't call it expanded air, because the radiator vents were all open and they were just allowing regular atmospheric pressure to come in. And so I don't know if that's what he was talking about in that section of the book, but at any rate, the pressure is now dropping back down a little bit, and I expect that the pressure will go back down just below 1. Once that air is expelled from the radiators, the steam will get into the radiators, and the steam will start to condense, and that will reduce the pressure in the entire system. So if you think about this time just after the CycleGard kicks back in, there's a cushion of air in each that's been introduced into each radiator and maybe even into each radiator runout, or certainly some of the radiators and some of the runouts. You can't. It's hard to predict exactly where the air is going to flow. It's going to flow wherever it's easiest. But all my radiators have similar slow venting on them. They're all like 4s and 5s. So the radiators, to some extent, I'll pull some air in. Well, that air cushion is there. The steam bumps when it gets created again. When the boiler started, it bumps into that air, and it can only push it out so fast. And unlike the original call for heat, the runouts are all hot. They're all steam hot. An original call for heat, the runouts are all cold, right? So the steam is, a lot of pressure gets used up, so to speak. You know, the steam gets used up to heat those runouts. So you don't see the pressure rise during that time. And then when the steam gets into the radiator space, it's obviously going to be condensing a lot in the radiators, because the radiator's job is to condense steam. So they're condensing a bunch of, all the steam that this boiler can produce gets condensed by my radiators because it's approximately correctly sized. It's not an oversized boiler. So that's why the pressure never rises during a normal call for heat. But then the CycleGard comes in. Sorry, I keep repeating myself, but it's an interesting topic, and I think about it, the more I talk about it, kind of the more I think about it. So sorry about that, but radiators all inhale that air. Then the steam comes back again. It doesn't have to expend any of itself heating the runouts. They're all steam hot. The mains obviously are all steam hot. And the radiators, the beginning part of the radiator is all steam hot from the previous, 15 minutes of the call for heat. But what it can't do is it can't shove the air out of those radiator vents fast enough to avoid raising the pressure a little bit. And you still see the pressure still is a little bit over 1 now. So it still hasn't recovered from what it was just before the CycleGard shut off. So that's an interesting effect that the CycleGard has. It actually resulted in a little bit of an increase of pressure in my system. And I don't know if I'm going to keep this video running and see over the next 15 minutes if the pressure drops or not. It could be that what will happen is some of the smaller radiators' vents will close. So upstairs is where my small radiators are. And their vents could start to close, and when that happens, the pressure will start to rise, because that means those radiators are all full of steam, and they're fully condensing, and they're small radiators, so they're not condensing as much. But they kind of come out of the system a little bit, as far as, letting the steam fill the system. Those radiators get completely full of steam, and then they settle into what their sort of operating maximum condensation rate is. Before the radiators are full of steam, in my mind, they're operating beyond kind of their normal condensation rate, because the radiators, some of those sections are cold, they're room temperature, or they're somewhat colder than steam temperature anyway. Let's say they're 100 degrees. The steam is going to condense to heat those sections at a rate that is faster than when the entire radiator is full of steam. So, if that makes sense, I see a rate where the radiator is full of steam as being sort of their nominal condensation rate. That's what they'll condense when they're fully heated up. And that's what starts to happen here as the call for heat progresses. Might as well keep this going. Like, YouTube's free, and you can turn off the video if you get bored, or you can fast forward it till something happens. You can fast forward it till you see the pressure change on the gauge here. So it's creeping up again. So I'd say we are definitely having some of the smaller radiators getting full of steam. It never did go back down to the 0.7 to 0.8 inch of water pressure that it saw before. Probably somewhat coincidentally, you know, around the time of that interruption, some of the radiators started to fill up. Alright, we're getting some more climbing now. Potentially another radiator vent closed. Indicating that that radiator is full of steam and is now at its, again, I don't know what the word for this is, its normal full condensation rate. Now I normally have this low pressure switch operating so that when the pressure gets up to 5 inches of water, it fires off a delay relay that's in series with the thermostat that will cut off the call for heat, and it delays it for something around 10 minutes or so. Just because I don't like it once the pressure starts to get full. I don't like the boiler to keep running when all the radiators vents are closed, because I don't know, it seems it's not really wasteful. All the heat generated is going into the room, but those radiators are all going to be about 200 degrees all the way across, and I like to just turn off the boiler for 10 minutes or so and let those radiators radiate their stored heat into the room. And it ends up being a little bit of an anticipator, because it's during a normal call for heat during the winter, it's pretty common for during that rest phase for the thermostat to be satisfied, so that way I don't overshoot the thermostat. Alright, so the pressure's actually dropped a little bit now from where it was. I don't really have an explanation for that. Could still have been having some of the radiators with that air in them potentially. And now that air worked its way out and the steam is in that radiator. I know the steam was in some radiators already, but I suppose this moving up and down, again, I don't have like information about the state of each of my 7 radiators in front of me at any moment. That'd be kind of cool, but I don't have that. But you know, if you see the pressure go down, there's no magic involved. The steam was going somewhere. The constant is the boiler is generating the same steam per minute or per second during this time, in my opinion. There's no trickery with the boiler. It's just putting out steam. And so when this pressure goes up and down, the only possibility for that in my mind is some change in the radiators. Either the radiator's vent is closing, causing steam pressure to rise, or some air that was in one of the radiators gets moved out, and steam can more completely fill that radiator, which leads to more condensation occurring at a faster rate. That's going to make the needle go down a little bit. Those things could be happening at the same time or overlapping times, which leads the needle to do whatever. So those are the mysteries are the state of any given radiator in my system at any time. I don't have a display showing, the vent state of 7 radiators sitting here in front of me right now, or the presence of steam, in a given section of whatever radiator at any time. But in my observations, this is where it sits, in the 0.5 to 2 inch range, something like that, during a call for heat. Now the next time, let's see, we're 19 minutes into this video. So the CycleGuard is going to cancel the call again so it can do its test. And it's going to cancel it for a minute. And we're going to see that occur, provided we don't meet the thermostat. I forget what I've got the thermostat set at. But we're going to see this occurrence again where okay, there it goes. So the light came on. So the radiators now, if the vents are closed, they're gonna stay closed, and they're gonna not allow air to enter them. Okay? Any vents that are open, they are going to allow air to come into them. So if it's just a couple of the vents that are open, a lot of air is going to get pulled in to those radiators over the next 45 seconds. And we may see that an amplification of this pressure rise that occurs once the boiler starts up again. So I think we're at a lower more intense vacuum than we were the last time. What did we get to? -2 before? I think that we only went to about -2 last time. So it's deeper this time because there's more steam in the system, and because I presume that some of the vents are closed. Alright, so the minute's up. This is why I left the CycleGuard on here. It's just a minute. So during that minute, the radiators are still pumping heat into the house. As a resident of the house, you can't notice the CycleGuard. Only if you come down here, or if you're listening for the boiler, if you can hear it. If you have a blower on your boiler, you're going to notice it a lot more than what I do with this atmospheric. Like, I can hear this thing when it comes on and shuts off, but I know that my wife can't. Or she's never said anything. Alright, so it's pumping out steam again at the rate it was before. We're going to see the pressure rise here. I'm curious to see if it rises more this time. I suspect it will. I think I've seen before when I've been watching it, and when I had this switch activated like I normally do, that it could actually activate this switch after a recovery from the CycleGuard. And it's not optimal probably, but it never bothered me that much. Like I said, the radiators are still putting their heat into the room. No gas is being burned during that time, so I mean, if you looked at the very fine thermometer up in the living space, you'd never really notice it. I've kept my eye on it quite a bit, and you don't really notice, okay, the boiler's resting, but it's 10 or 15 minutes of fuel that's not getting burned for really no difference in noticing. The thing I have noticed is if I do a setback, which I do in the morning, kind of just to see how this system runs with the switch. If you do a setback, it takes longer to recover from the setback. But I like it, because like I said, when there's 5 inches of pressure on this system. Every radiator vent is closed for the most part, and I don't like the boiler to run when every radiator vent is closed. I want the radiators to just give up their heat for a while and not be burning that gas during that time. I don't really see the benefit of burning the gas when the radiators are all full of steam. All right, so the pressure did go up a little bit more than last time, but it wasn't too bad. What did it do? Go up a little bit over 2? I wasn't watching that closely. I think it went up between 2 and 3, and now it's settling in just below 2. So I think we're where we were before that last interruption by the CycleGard. And this is a little bit of a recovery from a setback because I had the system off for a while to let the temperature go down. I'd let it go down to about 69, and normally I have it set at 71. So what we're experiencing here is just a 2-degree recovery. Normally, the boiler wouldn't run this long on a normal call for heat. So yeah, so there it is, 2 inches of water. Like I said before, I'm pretty sure at least some of the radiator's vents are closed to be able to see this much pressure. And that's what happens when the CycleGard kicks in. So I hope that was informative and can alleviate some of the CycleGard hate that's out there. Doesn't really hurt anything. The gas valve is rated for like 200,000 cycles, and that's rated for, so that means a typical one can go way longer than that. And by the time it's 200,000 cycles, I mean, whatever, it's going to be years from now. So years from now, if the gas valve fails due to the CycleGard turning it on and off an extra time per call for heat, well, I don't know, to me that's fine. It's a very good check for the water level to let the boiling come to a stop and see where that level is when the water's not boiling, to be sure you've got water in your boiler. Because as we all know, the Hartford loop isn't doing anything. Have a good day.